Oh, there it is, EXL 307. This afternoon we're going to talk about load balancing with Exchange 2010. How many of you here are running Exchange 2010 today? Wow, so you already configured your load balancer, so you're all good to go, right? How many of you? So we started doing this session about a year ago at our internal Tech Ready conferences at Microsoft. And the way we kind of started out is we say, we go back in time to the late 90s and early 2000s. What we found is that a lot of Exchange people became storage experts. We had to work with the storage team to kind of carve out storage in a certain way to ensure that performance was maintained and we didn't have a degradation of performance on the Exchange side. And as a result, we released tools such as the storage calculator, and we helped you understand the concepts of RAID and parity and striping and LUNs and everything else that came with the shared storage model to optimize storage. You learn the language of the storage team so that when you had the conversation about setting up storage, you could ensure that both people knew what each side was talking about. By the time Exchange 2007 shipped, we had introduced a lot of security options around certificates, and so you kind of became a certificate expert around subject alternate names and some of the new options that came in there. With Exchange 2010, we moved the client access, or the clients, right, so that all clients now fell behind a load balancer to talk to CAS, and that was the method for clients now to talk to their Exchange backend mailbox server. So it's client to a load balancer to a CAS array, and then those CAS array will, the servers in that CAS array will pull the mailbox in the appropriate mailbox server. But what we found is that we didn't have that same level setting of what are the load balancing concepts, what are my routing options as I go through and configure my load balancer, and the Exchange team and the network teams, right, had this disconnect on communication. So the first 30, 45 minutes of this session is to explain to you kind of the fundamental or primary concepts of load balancing. We're also going to include in that the concept of persistence and how persistence how come I'm not going forward? There we go. Persistence with Exchange 2010 and all these different persistence options and how you would configure your load balancing infrastructure to accommodate the requirements that Exchange will place on it. And in the last 15, 20 minutes, we're actually going to go through a demo and set up a load balancer for you to load balance Exchange 2010 and show you some of the things you can do around load balancing configurations and options that you would have learned in the first 30 to 45 minutes today. So to start out, we need load balancing because if we go back 20 or 30 years, we just scaled up. We put more processors into your mainframe or your mini computer, right? We added additional memory or capacity there. All clients were going to that one large monolithic entity. But as we went into the late 90s and through the 2000s, we're seeing now that this concept of scale out has kind of overtaken the scale up. So most organizations are deploying lots of commodity, cheaper servers. The catch with that is that when we have a browser-based client, or for some thick clients, right, there's no way for that client to know which of those endpoints to talk to. And so this concept of load balancing has arisen. And we have a couple options for that. With Windows NT4, we introduced the concept of software load balancing, right? So we have Windows Network Load Balancing. And we've had this technology in Windows for the past 12, 15 years, but there are some issues with Windows Network Load Balancing. So we call them out here, right? If you configure Windows Network Load Balancing, sometimes your network team gets upset. If you're using unicast mode, you can get problems with switch or port flooding, for example. Windows Network Load Balancing only supports one persistence option, which is source IP. And we're going to talk a little bit more about the concept of source IP and why that limits some of your capabilities in a load balance environment later. We know that when we have high traffic volumes, our throughput scales back dramatically once we go above 8 nodes. And so we kind of have even though we can deploy larger WNLB clusters, we do have a performance issue once we go over 8. Service awareness, Windows Network Load Balancing is not service aware. So if one of those nodes is down, clients will continue to be directed to it because there's no health check to say, is the actual application healthy on node 3 inside of that array, for example. And then for some more complexity, with Exchange 2010, we have the concept of the database availability group. The database availability group requires Windows failover clustering, right? We call Windows failover clustering setup under the hood when you create a DAG, and therefore deploy behind the scenes a Windows failover cluster. We also introduced the concept with Exchange 2010 of what we call the multi-role server. So deploying your CAS Hub mailbox roles all on the same virtual or physical instance. and therefore having a brick-like deployment model, right? So you've got Exchange servers, all of them are configured identically, and essentially you've got server plus storage, as Robert Gillies calls it, a man and his dog, right? A very simple deployment model, very simple operational model. The catch is, we also need to have some sort of load balancing for those CAS array members, and we have Windows failover clustering for the DAG members. So we went to the Windows team and said, hey, we'd like to talk to you about running both Windows failover clustering and Windows network load balancing on the same box, right? One providing resilience for mailbox, one providing resilience for CAS. And they looked at us, you want to do what? Failover cluster, why are you doing both, right? And essentially, because we're running multiple types of services in Exchange, one leverages the failover clustering component. We use that for the heartbeat availability component in the DAG, but the CAS array needs that load balancer as well. And so what we have is a scenario where if you choose to go with a multi-role box, we can't use Windows network load balancing there because we've already got Windows failover clustering installed. Also, if you're adding and removing a single node, that can sometimes cause all clients to reconnect. But essentially, we've got a list of issues around Windows network load balancing. It will work. We have plenty of deployments that are either smaller or lower scale, where Windows network load balancing will suffice for that traffic purposes for Exchange. But as your organization either grows or has scalability, or you want to do health awareness, for example, you're going to get into the network load balancer, or as they're rebranding themselves, application delivery controller space. And so initially, what they were doing is providing this concept of a single IP address for clients to connect to, and routing that to the appropriate clients inside of that array. Over time, especially the last few years, they start to do more, right? So now these devices are doing not just load balancing, but we're also doing perhaps pre-authentication in your perimeter network. There's some compression of attachments to ensure that clients coming in over a WAN or low connected network will have an optimal speed or attachment experience, right? SSL offload or bridging becomes optional, so we can decrypt the SSL stream at the device and then optionally re-encrypt it later. We'll talk more about the pros and cons of that in a little bit. And at the higher end, and as you start to get into the expensive models, right, you're going to get these options around rate shaping and packet stream modifications, where we're doing window sizing and things like that dynamically inside of the session. So the advantages are more now than just having an IP address that's being load balanced around array members, but we're really doing a lot of traffic shaping and monitoring for high traffic volumes and flows. And so thus, you will see on the marketing side this concept of application delivery controllers. But at the end of the day, what we're really, I think from the Exchange side, it's also known as a load balancer. If you talk to the technical people, it's often still called a network load balancer. So one of the first hurdles that you'll have when you're talking to your window or to your network team is this concept of routing. And so there's three options really for your Exchange infrastructure to route packets back to clients once you've deployed a load balancer and a VIP in front of them. One of them is called SNAP, and we've got some walkthroughs. We're actually going to have some animations to walk through each one of these, or Source Network Address Translation. Another one is we can configure our Exchange servers to use the load balancer as their default gateway. And so that way traffic from Exchange is going back to the load balancer, and the load balancer will route it back to the appropriate client. Another option is called direct server return. And we'll explain that one, but we don't like to recommend direct server return because it essentially is adding some complexity that's not a lot of value for Exchange. And we'll talk a little bit more about that one as well. The other piece to be aware of is there's this terminology in load balancing, right? So we've got one-armed and two-armed, and what is persistence and what is DNAT? And so there's these options as we're going through your configuration. They may ask you, well, what persistence options do you want for OA? And you'll have to explain, right, what Exchange would like to use for OA. We'll walk through those portions for Exchange in a couple of minutes. At a high level, one-armed and two-armed are relatively straightforward. One-armed says that my load balancer and my servers and my clients are all attached to the same network subnet. And so I literally have a 10.1.5 address space. Everything has a 10.1.5 IP address, right? So the concept is there's no straddling involved, not multiple network subnets. Two-armed says the load balancer has an internal and an external interface. Servers associated on the internal side, clients out on the external side. The VIP, therefore, is on the external side. The server IP addresses are on the internal side, and the load balancer is therefore straddling both networks and doing that to provide client access from that VIP back to our servers. It gets a little clearer if we actually draw it out, right? So single-arm configuration, we have a flat address space here. We have both our load balancer, our clients, and our servers. Load balancer is going to have a couple of IP addresses. One is its management IP, or its network interface, right? But it'll also have a virtual IP address, or perhaps multiple of these if you're load balancing Exchange and SharePoint and other applications as well. So first request from the client is going to perform a DNS lookup for mail.fabricam.com, for example, and that's going to resolve to the load balancer VIP. So we have a VIP associated with that DNS namespace. Packet goes to the VIP. With SourceNet, what the load balancer then does when it sends the packet to our Exchange CAS server is it changes the source IP. So when the packet goes from load balancer to CAS, the source IP is no longer 201. The source IP is now 5.11, which is from the load balancer. So with SourceNet, we have no extra configuration on Exchange. Exchange gets a packet from .11. Exchange processes that packet, replies to .11 with that information. The load balancer then changes the source IP back to the VIP, so the client, which sent a request to .31, receives a reply from .31 from the load balancer. So from the client perspective, I initiated my communication to 31. I received a reply on 31. From the load balancer perspective, I received a request from 11. I responded to 11. So there's no additional network changes required at the client or server level when we deploy SNAT as our routing option for load balancing. Let's take the same look at this flat network space, right, where we don't deploy SNAT. So now, source packet comes into the load balancer at 31. Load balancer chooses one of those array members, so in this case, CAS02, right, but it doesn't change the source IP. So now the Exchange server has received an IP packet, right, from .201 or from the client, processes that information, and then Exchange is going to reply. But the reply is going to go to 201 because that's where the request came in from. We need to do some additional configuration on Exchange because, as you notice, when Exchange sends the packet back, it doesn't use 82 as the reply address. It uses .31. And the reason for that is that the client sent the request to .31. If the request comes back from .82, we have a problem, right? It looks like spoofing. There's a security problem here, and the client will reject that packet. Our Windows OS will say, that I sent a request to 31. I don't understand why I'm getting a reply from 82. So there's additional configuration required to do direct server return. We'll show you how to do that, but we don't recommend it. And then finally, there's the concept of dual ARM. This is the one that you're probably most familiar with, or the most common deployment model. In a dual ARM scenario, we have two network spaces. One network space is for our clients, one side is for our servers. Source address comes in, right, to .31. The load balancer will do SNAT, but in this case, it's going to do it on the 172 network. The packet goes to CAS. CAS sees that the message came from 172. CAS replies. Load balancer replies with the .31. Client is happy, server is happy, and we've achieved an isolation, in effect, of our server infrastructure from our client infrastructure. So we can do this to reverse proxy or publish to the internet, for example, or to untrusted networks inside of the organization. So direct server return, as we said, we've got a slide for reference here of how to configure it. Where this often comes into play is organizations that are doing things like movie streaming. They don't want the return traffic to go through the load balancer because that's a very high level of load, and therefore it's a more expensive load balancer to handle both the inbound and outbound traffic. At high load levels, direct server return becomes optional, so we have the information for you here for reference, but like we said, typically we'll see organizations deploy SNAT. With SNAT, we also have this conversation about an SNAT or an SNAT pool. The reason for this is that each time we have an IP conversation, there's a source IP address and a target IP address, and a source port and a target port. And when we go through all the extrapolations, that means we can have 65,535 concurrent communication sessions on that per node member, right? And in some cases at extremely high volume, you can see that number, or that ability of connections to be constrained. And so therefore, we want to provide more than one IP address that the load balancer uses for SNAT. And what that gives us is 65,000 per IP address versus 65,000 total, right? And also, this is per CAS member. This is not for all CAS servers in the array. So it's not 65,000 for all 10 servers. It's 65,000 per individual CAS server, because each CAS server is a unique source port, target port combination pair. If we use SNAT pools, there is a concept then of the MAPI and how MAPI interacts with this. So if we decide to deploy an SNAT pool, we have to use the same SNAT IP address for each client that's coming inbound. With MAPI, each client may open multiple requests, right? So we might have a request for directory, a request for public folders, a request for mailbox, etc. Each one of those is going to be a connection. Those connections must be aligned to the same SNAT IP address. So essentially, when client request 1 is SNATed using IP1, and that same client issues a request that is then uses SNAT address 2 in the pool, that will break the MAPI communication stream. It's possible on some load balancers to configure a pool, but also link that to the same client requests, or you can break it out to have multiple VIPs if you can't have that linking of client address to the same IP address in the SNAT pool when we're doing SNAT. So 2 fixes, right? Turn off the pool and use a single IP. That will ensure you have a max of 65,000 connections per CAS server in that array, or use a pool, but configure your load balancer to ensure those connections are maintained for each client to the same SNAT address in the pool. Additionally, there's this concept of node, host, member, and server, right? So in this case, it's relatively straightforward. The member is when we talk about an IP address plus a port. So a node is a member of the CAS array, CAS1 or CAS2, but a member would be CAS2 on 443 or CAS2 on port 80, for example. One more piece to consider is client logging. When we're doing SNAT, there's the concept of the server logs on CAS. See, the source IP is always that same SNAT IP address from the load balancer, right? So we might have all of our clients. Doing troubleshooting then means that on the CAS servers, when we're looking at the logs, we're only seeing the SNAT address. We're not seeing the actual client addresses that are coming inbound. The load balancer is translating them as they hit CAS. As a result, it becomes more difficult to troubleshoot. However, we have an option in SP1 with Exchange now called the X-forwarded header, which will allow us to log which client it was on those server logs. So if you do need to do troubleshooting, use the X-forwarded header with SP1, and you're able to go. Question?
Yeah, how does that...
The X-forwarded?
Yeah, how does that relate to like the listeners you have, like if you want to only allow
Yep. We're going to pull that one to the end. I actually left off some of the data on this one. The slide notes will have a significant amount more. As another piece of reference information, I meant to say in the beginning, there's about 15 or 20 hidden slides in this deck. And so there's a lot more content than I can fit into the 45 minutes or 60 minutes of talking, but we have more detail in the full deck that you can download. So, and we'll take questions at the end as well to go over some of those the more advanced concepts. So, summary of your routing options, right? SNAT, the simplest, no modifications required on CAS or your clients. We're not setting up any loopback adapters or things like that. No routing changes, right? But we have this issue of the client IP not on the server logs. Direct server return, we've got some modifications to CAS. We've got some routing changes. We're basically adding some complexity inside of the organization. We're reducing some of our persistence options. With direct server return, the load balancer isn't aware of whether that connection is current or not because the server replied directly to the client. So it's not, you have to increase your timeout values, otherwise the load balancer just will time out the connection, right? So we have some concerns also around persistence and timeouts when using direct server return. And finally, load balancer is the default gateway. The big advantage here, right, without SNAT, now the client IP can show up on the server log, so we don't have to use the X-forwarded header. In general, we typically recommend SNAT, but we do see both SNAT and the load balancer default gateway being deployed. All right, so that's the overview of the concepts around routing and load balancer terminology. Now let's talk a little bit more around some Exchange-specific aspects for this. The first one is this concept of persistence, also called affinity, also called stickiness. What this says is that when I have a request coming inbound from client 1, and that request goes through an algorithm on the load balancer, and we pick CAS server 3 in the array, that all future requests from client 1 also go to CAS server 3. And so for some Exchange protocols, we require persistence. For some, it's optional. For some, it's not required at all. But when we're doing persistence, we have multiple ways to do this. One is that every SSL session has a session ID. And so we can look at that SSL session ID and then use that to track, make a table, right? And then use that table to ensure that all the clients always connect to the same server that they talked to initially inside of that pool. Another option is to use what's called a cookie. And we have both load balancer generated cookies and application generated cookies. And these are just the web browser cookies. We're actually going to show you the cookie in the demo at the end here. Cookies means, however, that we have to decrypt the SSL stream, which means we need a certificate on our load balancer so that it can look inside of those packets and actually either pull the cookie out to, if it's an app-generated cookie, or add a cookie, for example, if it's a browser client. The simplest option is something called source IP. We just use the source IP of the client, and that source IP will always go back to the same CAS server in the array once the first one is picked out, right? So source IP address is the simplest, but source IP address doesn't always work for us. We'll explain some of the issues with source IP going on. There's a concept of universal persistence, destination address, RDP, SIP, right? There's multiple persistence types. But in general, we're going to look at SSL session ID, cookie, and source IP when it comes down to Exchange. Persistence, as we call out, is separate from your algorithm of which server to pick. So we don't necessarily have equal load distribution with persistence, right? Persistence is just ensuring that certain clients always maintain their connection to the CAS server that they first talked to. And so when they close their session, so that day one, for example, my machine might go to CAS server 3 in the pool, and eventually I'll shut down Outlook. Day 2, the algorithm might have picked CAS server 6 for me, but I will maintain then CAS server 6 throughout the duration of that Outlook session. That's called persistence. So as we said, though, cookie persistence is becoming very prevalent for the browser-based ones. We also have some support, as we'll mention, for Outlook 2010 coming later. But cookie persistence does require us to decrypt the stream. If we can't decrypt the SSL stream, we can't read or insert a cookie, and so therefore we don't have any of these cookie persistence options available. Finally, we have this concept of where traffic flows inside of Exchange. And we think, oh, let's put a load balancer in front of Exchange, right? Well, does that mean in front of internal clients, external clients, or Exchange-to-Exchange proxying? If you have more than one Exchange site that has CAS servers, we have this concept of proxying and redirection. And in some cases, we'll want to load balance that traffic because some of those protocols do not automatically load balance traffic between Exchange sites. The reason we put this out is that the concept of a single VIP may not be adequate for all deployments. You may have one VIP for external clients, which has a certain type of authentication and persistence. You may have a separate VIP for internal clients, which has a different authentication and or persistence option types. We also have the concept of NAT and non-NAT. And we're going to show you in a moment why that makes a difference in determining how many VIPs you need and where those VIPs are placed on your network. So we talked about source IP as the simplest. Source IP is very easy because no table needs to be maintained. The load balancer looks at the source IP address, says, aha, I will always give that IP address, CAS server number 4, and every time a request comes in, it goes to CAS server number 4, right, for the duration of that session. The problem is, if we're using NAT in the environment, we can have one of our CAS servers in the organization get overloaded. So request comes in with OA, for example, on 10.18.7.3. We pick CAS server 1 as the first one. Next request comes in from 8.5. Our choice algorithm says, oh, I already sent one to CAS 1. Let's pick CAS 2 for the next client, right? So now future requests coming in from 3 go to 1 for the duration of that session, and 8.5 session goes to CAS 2. We also have some clients that are out on the internet, and those are being routed or NATed as they come through to our internal infrastructure. So client comes in, it's NATed. The source IP address now of this client is going to be 10.15.8.1. Hits the load balancer, says, okay, that's a new request. I'll give it to CAS server 3. Another client from the outside or behind a NAT device, right, comes into our NAT device. NAT device then talks to the load balancer, 8.1. Load balancer says, oh, I'm using source IP. 8.1 goes to CAS server 3. So where does the next client go to? CAS server 3. And every client behind that NAT device with source IP as the persistence type will now go to CAS server 3 inside of that array. Essentially, that means that CAS server 3 becomes overloaded when we use source IP as the persistence type. What's the fix? Let's decrypt the traffic and use cookie-based load balancing, right? With cookie-based load balancing, we can give, even though all those requests behind NAT come in with 8.1, we'll use cookie as the persistence method instead of source IP, and now we're able to redistribute that traffic inside across all of those other CAS server arrays. And so you can see a benefit for cookie. So source IP is the simplest and easiest to deploy. However, there's a problem when using NAT. So if you're using NAT, we like to go towards cookie-based persistence options. The second one is that when we talk about Exchange traffic, we're not just talking about one traffic type, right? We have Outlook Web App and Exchange Control Panel, which are HTTPS-based protocols and browser clients. We have Exchange Web Services, which might be a specific application or something like Link talking to us. We have ActiveSync. We may have POP or IMAP, Outlook Anywhere, Outlook Mappy, Address Book Server, Remote PowerShell. All of these client types coming into Exchange, or these Exchange protocols, have different requirements around persistence and stickiness. And so therefore, carving up our concept of VIPs and how we assign persistence has to be done on a per Exchange workload basis. This also comes into the question of, do we use a single VIP for all the workloads? So we have one namespace, mail.fabricam.com. That goes to one VIP, and all protocols will flow through that. So I have a large amount of configuration on that VIP to break out the different persistence options by workload. Or do I go with multiple VIPs, right? Multiple VIPs, say I have mail.fabricam.com for Outlook Web App, but I have mobile.fabricam.com for ActiveSync, and I've got outlook.fabricam.com for Outlook clients. Now I have 3 VIPs. I have segmented my traffic, which means that my configuration per VIP is a little simpler, but I've increased my management at the load balancer level, and I've increased the number of namespaces that may be exposed to users. And so there's not a magic answer of do you go single or multiple. Single is one namespace for users. Multiple is greater administrator flexibility, right? And so you'll have to kind of carve out what's the appropriate mix there between 1, 2, or multiple VIPs for the different Exchange workloads. The second piece is that with these Exchange workloads, in some of them we require persistence. So for Outlook Web App, ECP, EWS, and RPC CAS, or also known as Outlook Mappy, right? We require persistence. All client communications in that session must go to the same CAS server in the array. For Outlook Anywhere, ActiveSync, Address Book Service, and Remote PowerShell, we don't have to. I can send request 1 for ActiveSync to CAS server 2, and I can send request 2 from the same ActiveSync client to CAS server 3. It will work, except that we'll see a performance impact on CAS. So that second CAS server has to re-authenticate the client. We see additional processor overhead, essentially. So client types in the middle column, we do not require persistence, but you'll see lower processor utilization if we have persistence turned on. And then finally, for offline address book, AutoDiscover, POP, and IMAP, each request is a single request, and the next request also contains credentials and authentication. So we do not require those requests to go to the same CAS server. They can go to any CAS server in the array at any time. So when we don't require persistence is these protocols, right? POP and IMAP, all the information is contained in the initial request, and the reply comes back with that info. A second request is completely net new, and therefore no persistence is required. So for the ones that require and recommend persistence, let's look at what our persistence sort order, our recommended options are around that. So first of all, right, Outlook Web App and Exchange Control Panel are what we call stateful. So you send some credentials, we issue you a cookie, we use that cookie for your access throughout the duration of that Outlook Web App or ECP session. So if we send that cookie to a different CAS server in the array, it did not generate that cookie, and so therefore it wants to re-authenticate you. Your entire OA or ECP session is then lost, right? So as a result, we need to maintain persistence for OA and ECP. We can do that a couple ways. We can do that with the Exchange-generated cookie, right? So for OA, we use user context. For ECP, MSEXCH, ECP Canary. Or we can have the load balancer insert a cookie, and the load balancer cookie is used to maintain persistence. Or we can use source IP, right? Source IP is the simplest option. Because these are HTTPS-based apps or browser-based clients, we prefer cookie persistence. That gets us around the issue of NAT in the environment, so we don't have that overload of servers. ActiveSync doesn't require persistence, but we see a performance benefit if we turn it on. ActiveSync clients are not browser-based clients, so the concept of an application cookie doesn't work, right? We're not going to be sending cookies back from browsers on an ActiveSync phone. But ActiveSync does typically leverage basic authentication, and with basic authentication, we have this authorization header that's sent with each client request. So we can have the load balancer leverage the ActiveSync authorization header to maintain persistence for the duration of that ActiveSync session. Other options would be client IP. In some areas of the world, the carriers give public IP addresses to devices. So I have a wide range of source IP addresses. Therefore, I have a pretty good mix of which servers are deployed to. In other regions of the world, the carriers use NAT. And so all the clients are with a 10 address space, for example, right? But they're going through a NAT device before they hit Exchange. That would mean that your 30,000 mobile devices might be represented by 2 or 3 or 5 IP addresses coming into Exchange. And as a result, source IP could then tend to overload one of the CAS servers inside of your organization. The other option is SSL session ID. All ActiveSync traffic is encrypted with an SSL session. The catch there is that some clients create a new SSL session ID inside of the same stream. And so that breaks the concept for those specific clients. We are working with the ActiveSync program to come up with ActiveSync logo devices. So this summer we'll have a devices certified for ActiveSync which meet a specific set of criteria. But for devices prior to that, you'd have to work with the devices you're using to see if they're creating new SSL session IDs or not. EWS is a stateful protocol as well, so requires persistence. We recommend a server or load balancer generated cookie there, or SSL session ID. It depends on your EWS clients or endpoints. Persistence issues, the original Office Communicator Phone edition, for example, doesn't process cookies, and so therefore cookie-based persistence for that client type isn't relevant. But typically newer clients for EWS are aware of the concept of cookies, and will there process them, we can use cookie-based persistence. Outlook Anywhere is interesting. Outlook Anywhere is coming in over HTTPS. It then gets converted to RPC traffic, right, not the RPC endpoint. But Outlook Anywhere persistence is recommended. The reason for that is we often see a lot of NAT, and because it's Outlook Anywhere traffic, we can't use cookies, right, or the load balancer generated cookie, because it's an Outlook client responding, not a web browser client responding. So we can use client IP, which introduces the NAT issue. Or if we have Outlook 2010, we've now introduced the concept of the Outlook session cookie. So we have a cookie application generated for Outlook Anywhere, but it requires a newer version of the client. Let's say you decide, well, I have NAT, so I have to use source, or I have NAT, I don't have Outlook 2010, therefore I want to use source IP for Outlook Anywhere. You can do that, or you can use no persistence for Outlook Anywhere. What this means is there's a chance that the clients will have RPC data in connections established on one of the CAS servers in the array, and the RPC data out connection established on a different CAS server on the array. The CAS servers have a way to deal with this. It's confusingly named the load balancing service. It has nothing to do with actual load balancing on CAS. But what it does is identify when the RPC data in stream and the RPC data outstream are misaligned for the same connection, and then moves one of those connections to the other CAS server so that they're aligned to the same CAS. So we see a performance hit. It's a few percent on CAS. Essentially, if we do not have persistence on for Outlook Anywhere, we have to do this LBS service behind there to realign the two sessions. So Outlook Anywhere will work without persistence, but we see a performance hit for CAS. Offline address book, client IP or SSL session ID will work. Obviously, when using client IP, we have to watch the NAT side. The biggest one, right, is the Outlook MAPI or RPC client access service. This one also requires persistence, or requires persistence. Our recommended types would be client IP, because that's the only one we have. All the other options, cookies, etc., do not work because this is a thick Outlook client. For load balancing or determining when the first request comes in, which server do we hit, we recommend that you use round robin, essentially saying that send the first request to 1, the next client request goes to 2, next goes to 3. Load balancing vendors will give you other options such as least connections, right? So you might think, well, hey, I would want to use least connections to ensure that I have more equitable distribution of my load inside of the environment. We had least connections on in Outlook.com and MSIT for a while, but we found some operational issues around that. One of them is we have a client or we have a server that we take down for maintenance, right? So we patch it, we put it back into the pool. Well, the load balancing algorithm says, oh, least connections. Look, I've got connections to 1, 2, 4, and 5, no connections to 3. All new inbound connections then go to server 3. Server 3 has just come back online. If we turn the fire hose onto server 3, we will see it not always able to process all of those inbound connections. With round robin, as we take servers in and out of maintenance, we're still going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Over time, we tend to see that harmonize and come back to an equitable distribution. So watch the method of choosing the member in the array when using, or when configuring your load balancer with a persistence option. The second piece to Outlook MAPI RPC CAS is the concept of static mapping for the RPC ports. If we leave the dynamic range turned on, what we have to do, or what the load balancer has to do, is maintain a table of all of those source ports for each client coming inbound, which consumes a lot of memory on your load balancers. By going to static mapping, we're saying we have 3 ports on all of our CAS servers that will be used, and it makes the sizing of that memory table smaller, which means that you can have a more effective performance effectively on your load balancer. We have the process for you, right? To enable static ports for RPC CAS, there's a registry entry that's required at RTM, plus modifying a file. In SP1, it's just a registry entry. So in SP1, you turn on static ports, go in the registry, configure the ports, and you're off and running. As we point out, it's not migrated on an upgrade. Make sure you set it after you upgrade to SP1. Finally, you said, wow, Andrew, that's a lot of information. I learned a whole lot about load balancers and this persistence thing with all these client workloads coming into Exchange. How do you keep track of that? So we have a table for you, right? What are all the Exchange workloads, and what is the Microsoft recommendation around which persistence option should be used? Also, you'll see that we put in there, what did we do internally? We don't always, MSIT does not always follow our application vendor guidance, because MSIT has some interesting scenarios. We often have beta code sometimes we have high load volumes, other pieces. And so we put both out there for your reference. You're welcome to take a look at both what Exchange recommends, which is the middle column, and what MSIT did internally, which is the far right column. The final one that we want to bring up is this concept of large-scale Exchange deployments, right? There's some unique pieces here when we get into high volumes of clients. Specifically, what we're talking about is this concept of a MAPI concentrator. So we talked about the concept of NAT, and how if you're using source IP for persistence, NAT can cause overload of one of the servers in the pool. The other way to do this is to have all clients go through some sort of MAPI device. So think of a BlackBerry Enterprise server or an archiving solution. All traffic is coming from that one server to one CAS server inside of the array. And so effectively what we're doing is consolidating a large amount of traffic and putting it all to the same CAS server in the array. The only solution for MAPI concentrators essentially is to create another virtual IP address, or to kind of carve off some dedicated processing for this if we have the volume of load that would merit that. So in organizations where we have this concept of a lot of clients going through a single server to get back to Exchange, we want to look at that load and make sure that we determine is it appropriate or not for that load to go back to the same CAS array infrastructure that's servicing our normal clients. As we said, right, there's also the question of single VIPs or multiple VIPs. Single VIPs is simpler from an end user perspective. I have one namespace. Internally, for Exchange 2010, we initially deployed with a single VIP. And it's very simple. As an end user of services, I put mail.microsoft.com into my browser or into my phone or into my Outlook client for Outlook Anywhere, and it resolves and everything works, and it's easy to remember. The people who don't like it are the ones who run our Exchange and load balancing infrastructure, because it makes their troubleshooting more complex. Going forward, we are evaluating our position on single versus multiple and trying to work out what is the right blend, right? Maybe for user-facing URLs, we use one mail.microsoft.com. For Outlook configurable URLs and Exchange Web Services, we move to a separate one because end users are typically not seeing those URLs. But there's this concept of simple for user versus simple for administrator, and in this case, they're diametrically opposed. So going through the planning process, you'll have the option to determine, do I want one namespace or multiple, and that's going to lead you down the one VIP or multiple. So segmenting traffic is, if you want to, for example, turn off ActiveSync or make an ActiveSync configuration change, today we have to modify this rule set with all of those persistence options, which is a little nerve-wracking, right? You're also potentially impacting Outlook Anywhere, Outlook Mappy, OWA, for example. In the future, if we were segmented, it'd be simpler to make an ActiveSync change because we know it's not going to affect the other traffic types. But like I said, that also means multiple URLs for users to know, which is a downside to the multiple VIPs. Another area that will come up is the concept of SSL offload versus SSL bridging. In SSL offload, the load balancer is doing decryption. So client requests our SSL to the load balancer. We decrypt the packets, and then the load balancer will send in those packets unencrypted or over port 80 to the Exchange servers. Benefits to this is we reduce the encryption load on Exchange CAS, so we increase our performance essentially on CAS. Why not do that then, right? Well, in some organizations, they require encryption end-to-end. So load balancer will decrypt, load balancer will do this cookie analysis or persistence types, right? And then re-encrypt coming inbound to Exchange. If you do have this requirement, one recommendation that comes out is to reduce the key size for the certificates that are on your Exchange servers to reduce the overhead on Exchange. It will still be protected by a SSL. It will just be a smaller key so you don't have the same performance hit. Your public key is 2048 or a high key length, right? Your internal key is 512 or a smaller number to reduce that load. How do you configure it? It's been a little confusing to find some of this information, so we've consolidated it all for you. But essentially, there's a couple, for each Exchange protocol, we'll have to go in and turn on the ability to listen over port 80. For Outlook Anywhere, we have the set Outlook Anywhere SSL offload to true. For OWA and ECP, we have to go into the registry and set a key, and then uncheck the require SSL inside of IIS. Once that's done, the Exchange servers will then listen on port 80, and we can have traffic from the load balancer coming in that's not being re-encrypted. For web services and AutoDiscover, also another process, right? So unchecking SSL. For SP1, we don't need to do anything for AutoDiscover. For web services, you'll have to change HTTPS to HTTP inside of the file. The last area is around timeouts. This is one of the areas where we've had a lot of questions of what should I set my timeout intervals to be on the load balancer? Because clients, depending on the Exchange workload, will have an expectation of a timeout value. The CAS server has an expectation of a timeout value, but so do the load balancers as well, right? We don't want to keep sessions open in that table and in RAM if that client is no longer online or active, so we can reuse those resources. So OWA and ECP, we set the timeout on your load balancer to be the longest session timeout that you have configured. So if you've got an 8-hour OWA timeout value, right, we want the load balancer to time out over 8 hours as well. It doesn't help us when the load balancer is set to 1 hour, your CAS servers are set to 8 hours, the CAS session stays active, but the client is forced to re-authenticate because the timeout hit or expired after 1 hour. For ActiveSync, we don't know yet, and part of the problem here is that it depends on the ActiveSync device and phone. So we need a little bit more standardization around ActiveSync to give you the correct amount of data of what that timeout value should be. Right now, the general rule of thumb, right, set your ActiveSync timeouts to 1 hour, and we're going to have more data on this over the next couple of months. Web services, it's based on your web services app, and Outlook Anywhere, 1 hour again. Set to 1 hour for Outlook Anywhere, and we should see the same timeout values from the Outlook and CAS perspective, as well as the load balancer. All right, so let's take a look, right? What does this look like? We talked all about persistence and load balancing and SSL offload and timeouts and everything else. Let's actually go and set up an Exchange infrastructure. We have a lab. In this lab environment, we have a single domain controller. We have 2 Exchange servers. Our lab has a soon-to-be released from F5 is a Hyper-V VM of their big, the F5 Big IP. So we can run now, or you'll be able to run within a week or two or near-term future, the same OS as the hardware load balancer in a virtual environment. So for lab testing, right, you can go in and now determine what your configuration is without having to have a separate load balancer in the lab. We've got a list as we close out the demo. There's actually multiple software load balancers you can run in VMs. We'll show you links to all of those that we're aware of and where you can find configuration guidance for that. So what I've done is actually we've moved the load balancer VM to a separate laptop. So on this one, we have DC1, Exchange 1, and Exchange 2. Let's take a look at how this works. So first of all, I'm running a 2-armed config. My servers are on the 5 network. There's also a management network of 1. And the client, or my host PC here, is on the 10 network. So if I RDP into DC02, for example, I can take a look and see what I have. So if I do ipconfig, right, I'm here on 1.41 and 5.41. And I've done some initial setup. So on our F5, we've imported a license key. We've also went in and set the 2 interfaces to 5.245 and 10.245. So I should be able to ping from my DC 192.168.5.245. We can. From my host, I should be able to ping the 10.245 address. And we can. And just to show you we're not up to any trickery, let's go back to our DC. We should not be able to ping the 10 address, right? We're not on the 10 network, and we don't have any routes to the 10 network from the DC. So we've also went into DNS and created a record, mail.fabricam.com. We've come up with an IP address for that. Let's see what that was. So if I ping mail.fabricam.com, I cannot ping that because that's on the 10 network. I forgot. Let's go back to my host. I had a little heart attack there for a bit. Let's take, now let's try pinging mail.fabricam.com. And I can see it resolves to 10.50, but I'm not able to ping it because I haven't went through the configuration process yet to set up a VIP and do persistence methods and everything else. Since we're going to be doing that, let's let this ping stay active, and we'll be able to come back and see eventually that VIP go active. At that point, we should be able to bring up an OS session, for example, and log in. But if we go back to our box, our load balancer interface or management interface is 192.168.1.245. If you forget what a default F5 IP address is, convert 245 from decimal to hex and you get F5. So that's easy to remember. So continue to the website, right? It's got a self-signed certificate on it. We use SSL to get there. I'm going to log in with a username and password that I've defined. And now we have, running on Hyper-V, a F5 big IP local traffic module, or what we typically would see in a, we call a hardware load balancer. We're going to try to make the screen resolution a little, or not the screen resolution, but the text a little larger for you. Does that help see the, that might be too big. Let's try 125 for that purpose. What we've also done, so I told you we set up the 2 IP addresses. We've also created a self-signed certificate on the box. So if I look into my local traffic module, I will see an SSL certificate for mail.fabricam.com. Normally what you'd be putting here is your public third-party trusted root certificate, right? So you're going to have a certificate you've requested. It's going to have your external namespace associated with it. You'll import it to the box. Now this box can decrypt and do that persistence options that we showed you about. We also had went in, as we showed you, and defined a couple of self-IPs. So if I look at that, I can see my 5.245 and my 10.245 addresses are defined. One's on the internal interface, one is on the external interface. You can obviously add more as you add services and other pieces here. But if we look, right, I go back to the load balancer configuration and I see that virtual servers. If I take a list there, I shouldn't see any. This is out of the box. If I look at nodes, for example, right, there's no nodes defined yet here, nothing running Exchange. So let's go and figure out how to do that. There's 2 ways to do this. One, we can go down. So Microsoft has worked with all the major load balancing vendors to provide the recommendations that you saw in the last 45 minutes so that they could come up with either a configuration template and or some published guidance of how to configure that respective load balancer for Exchange 2010. Most of them have released a white paper. We have a link coming later in the deck that'll show you all the white papers that have been published to date for configuring Exchange with your respective hardware load balancer model type. Many of them have also went in and developed a template to make it simpler for you to do. So as you saw, right, there's quite a bit of information in the last hour. I'm guessing many people may view the recording a couple times to catch up on that. But let's look at how it is with just a template. So I pick template, and we see that we have a wide variety of different applications here. But let's pick Microsoft Exchange 2010, right, because we're on Exchange 2010. and go through the process. So first of all, let's give it a name for our rule. We'll call it My Exchange 2010. The second question is, do these servers have a route back to the application clients and the big IP system? And the answer to that is, or have a route, right, is no. We're not going to use load balancer default gateway. We're going to show you the SNAT option for this configuration. So we don't need the load balancer to do the routing. We don't load balancer to use SNAT. We'll pick Outlook Web App. We could also pick the other ones, right? Outlook Anywhere, ActiveSync, and or AutoDiscover. And when we pick Outlook Web App, we're going to provide some information. So first one is, what IP address do you want to use for our Outlook Web App server? We've already went into DNS and carved out the 10.50, so let's put that address in, 192.168.10.50. And now we have this choice, right? What is the algorithm that we're going to use to determine the next client request, which server is going to be chosen? And so we've got, by default, least connections. That would give us the capability to say, whatever server in that CAS array has the fewest connections, the next client request goes to that box. But if you remember, we saw some operational issues there, right? So we like to use round robin. We're going to go and pick round robin. Now, I'm going to call out my Exchange servers. So 192.168.5.42 and 43. Let me confirm that those are up and available by pinging them. Mail, fab, exch01 is up at 42, and .2 is up at 43. We have the concept of health checking, right? So health checking is the device is going to periodically go back, check for service health. And so right now what it's doing is a simple HTTP GET request, and it's going to expect some response from the server itself. So if I look at my DC and actually go to HTTPS fab exch01, just right to the root, right? I see the default IIS page there. I can right-click on this, go to View Source. I see some information there, and I'll just put the string of text. This is what I would expect to see. So if I see this coming back, I know IIS is operational. If you look through the document, you'll actually see that you can do, for many of these, right, advanced health level checking. So actually doing a GET with the /OA and checking for the exchange-specific response. For the interest of time, we'll leave a simple response here as our simple health check. So in this case, we know IIS is up. We put more advanced information here. We'd actually know that OA is responding with the correct information. The next question is, are the clients on a LAN or WAN? Here's where we perform some WAN optimizations if the clients are remote or coming over a slower link. Next choice is, what certificate should be presented to clients, right? And these both of these options are for that. So we're going to pick the mail.fabricam.com self-signed certificate that we showed you a couple minutes ago. Finally, there's a question of, do we want to re-encrypt the traffic when we send it inbound or the next hop into Exchange? And I have not configured my Exchange servers for SSL offload. They are only listening on SSL today. So for that, we will come in here and say yes. Optionally, we could put a copy of the certificate that's on the Exchange servers onto our load balancers. What that would mean is that in the initial communication with the server, it would not have to pull down the certificate each time to do the encryption. It would leverage the locally cached copy to essentially optimize for time and for performance, right? In our case, I have not imported our Exchange certificates, so we're going to say none and none. And RPC CAS, POP3, and IMAP4 are not there, so we're going to just go finished. And it's going to take a minute or two for it to generate, basically, this Exchange configuration. We'll create the virtual servers, the rules, the pool, the health monitors, and we'll walk through and take a look at that as that comes up. So let's minimize DC01. Let's look at our ping. We should see in about a minute or so the ping come back with a reply from our virtual IP address of 192.168.1.50. Once that's up, we'll go back in and take a look. We should also then be able to sign into OA. We should see the Exchange CAS forms-based authentication login pages. And we'll also show you how to look at the cookie and do some troubleshooting around that as well. So now I'm counting up and watching the ping replies go by. You can download, so all vendors that have a virtual device have a trial version you can download for free with usually a 45 or 90-day license key coming out. Pricing for the software, the virtualized software equivalents is load balancer vendor specific. So some of them have certified their devices for production, but it would be up to your load balancer vendor to come up with licensing and costs around that. But for testing purposes, right, you go out and download it. I did this last summer for the first time and found it a very valuable educational experience. So let's see, come back. If I go back and look at, oops, I don't need this up. Let's watch. We're still generating. Yep. And our laptops are not the highest speed, fastest performance as what you may be running your virtualized infrastructure on. It can be a little faster, obviously, on some dedicated or full hardware. Question? Question is, have you looked at using the application request router, the IIS capabilities that might, in IIS essentially, or ASR? That would be a question I cannot answer. So there's some groups that are looking at the ASR capabilities, but whether exchanges, for example, is one that we just can't say yet. Come on. Yes, question. No, you're in the question is implementing a couple of CAS servers, right? Because there's two concepts. There's high availability and site resiliency. No, the concept for load balancing would apply for and once you go over one CAS server, you'll either need to use WNLB or a third-party hardware load balancer to do the load balancing. That's for each Exchange request type, right? So some require. All right, so we're up. Let's take a look now. And first thing we're going to do is try our browser and see if we can go to http mail.fabricam.com. And you'll note I'm not typing HTTPS and I'm not typing OA at the end, right? So I'm going to start that process. And while that's initializing the first time, we're also going to go in and see how that works. So if we take a look, we can see that all of these load balancer artifacts have been created by the template used for Exchange 2010. If I look, I can now see on my virtual server list a couple, right? So I see one is green, that's HTTPS. That's because there's a pool associated there and we're doing health checking. We have another that's blue, which says there's no health monitoring there. The reason is that's HTTP. If we take a look at this one, the OA virtual server, and I look at resources, what this is an HTTP redirect. So any request coming in on HTTP will redirect to HTTPS, which would then ensure that you hit the HTTPS listener, which is going to respond on that. If I take a look inside, right, I can see information on that, what the VIP address is, what profiles, some of the other pieces that have been created. I can see the SNAT pool is set there for automatic. I can click on resources, and I can see some objects there. We're going to do one modification in this demo, which is to come in here and turn off OneConnect. So one thing is that in our demonstration environment, we're doing HTTPS all the way back to our CAS servers with FBA on CAS. Typically, you'll be running some sort of perimeter authentication, and you'll come in with another traffic type such as NTLM. So in my lab environment, we don't need anything for OneConnect. Also, we don't need any of the advanced HTTP optimizations for Exchange. That's going to just run a little slower. So I'm going to turn both of those off, come back in and do an update. And that should happen relatively quickly. And we're back. So also, we can see that the pool was created, right? There's a pool list here of our nodes. We can see that there's a monitor for checking health. We know that we're looking for that IIS response. And we can see the nodes themselves, right? So if I look at the node list, I can see both servers. The nodes, so the health checking, as you'll notice, can occur in two places. One, at the pool level, which is where we've configured it, and we don't have any health checking at the node level. We could also optionally go in and turn it on here, but not required. So now, if we go back out, we should see, first of all, we got the prompt around security certificate. My device does not trust the self-signed cert, right? But if I go to continue to this website and take another moment as it initializes for the first time with our rule changes, we should see a redirect from HTTP to HTTPS and a redirect from // to // OA. So now I have a connection from this host machine through our guest network load balancer back to those CAS arrays on a separate network segment. And I should be able to log in. There's no redirect on the CAS itself. At this point, I can. So if I go to,
So is that an iRule that's doing that?
we'll show you that in a moment. Yes, it is. So if I look on, if I go to the internal network, right, on our DC01, and I try to go HTTP to fab, EXEH01, for example, I see IIS, but if I try to go to HTTP/OA, oh, there is a redirect on CAS as well, actually. I take that back. But we'll show you the iRule that's happening on F5. I didn't realize that my CAS servers had a redirect. I was going to show you that it wasn't there. Let's go back out. And first of all, we're going to go back to our load balancer config. I can bring up the right RDP window. And we'll see the iRules for that. So if I see iRules, there's two of them, there are a couple of them that will be relevant for Exchange. If I scroll down, I can see the OA append iRule. So here, we're doing an HTTP, any HTTP request that ends with a /, right? So no additional URIs would then get appended the /OA. So from an outside client connecting to the VIP, /OA will be appended automatically. There's another iRule here, if I back up, which is the SSL redirect right here. So this is any request that's coming in with HTTP will get redirected to HTTPS. And I can also walk back to, if I look at the virtual server where those would be linked back in. The other piece I wanted to show you was on the clients itself, right? So we logged into Outlook Web App. Let's take a look to see this concept of cookies and what cookies being leveraged here. So if I go to Tools in Internet Explorer and Developer Tools, I can go and wait. I can go to Cache and say View Cookie Information. So I want to see what cookies are being leveraged on this client. And I wait. And here are the cookies that are in my current browser session. So if I scroll down, I will see one, a user context cookie, which is the one being generated by CAS. But I can also see that my load balancer has inserted my Exchange 2010 OA pool cookie. And so it's using this cookie to basically ensure that all requests coming from this specific browser session go to the same CAS server inside of that array. Also pointed out as valuable is that the value for this cookie is actually a hashed version of the IP address of the server. So for troubleshooting purposes, if you talk to your load balancer vendor, oftentimes they'll give you the way to go backwards and find out from a client which CAS server in the array that that client is actually talking to. So from a client troubleshooting perspective, you can look at the cookie. If that cookie is using unique information on the server, you'll be able to backtrack that information. If your security group is concerned about that, most of them also will give you the capability for encrypting or not providing that sort of internal information back out to the clients, right? So to protect that from an external or a ability for someone to see what your internal IP address base range would be. So let's go back in, and we can confirm, let's just to show you, oops, I'll keep going to the wrong box. If I were to go, for example, from DC01, go HTTPS, mail, Fabricant, oh, not mail, but fab, either one of those servers /OA, and log in. We will not see that load balancer generated cookie because we're going directly to those respective Exchange boxes. Cache, not clear, but view. So when I look down now, I can see that I have the user context cookie, but if I scroll up slowly, I do not have a cookie being generated by the load balancer. All right, so there's our demo for how to configure it. Pick the template. Choose if you want to have some of the advanced, or what authentication options, for example, right, and or what health checking options you need for your services. And you've effectively deployed a load balancer in front of Exchange Server 2010. So with that, we actually have some of the F5 experts here as well. If you have some questions around load balancing. We'd be happy to take Q&A and answer any questions you may have. Thank you. If not, so I forgot to end a demo. The other thing we wanted to show you is there's some more content here, which is primarily for reference, right? But give you to point it out. I forgot that we're not doing the demo at the end. First of all, we have a list of load balancing vendors, which we've worked with to develop guidance. And so there's the website and associated ones. Also, we have a list of the virtual environments, right? So if you want to deploy a virtual infrastructure, Kemp, F5, and Citrix have all today released a publicly downloadable version of their hardware load balancer appliance. So you can do this. For some of them, it's trial version only. For some of them, it's trial version plus one you could put into production. There's also a wiki on TechNet, which includes the links to all of those Exchange 2010 guides I was talking about. So we keep this on a link in the deck because a lot of these guides are being updated every couple of months. And so we keep this link on TechNet active with all of the current hardware vendor load balancer guidance for Exchange Server 2010. The final one that we wanted to give you 5 minutes on is this concept of how do you do site resiliency automatically. And so there's a concept of I want to be able to do site resiliency without going through a data center activation process when one site is down or have automatic client failover. This process would leverage one of the global DNS load balancing solutions. So some of these are provided by hardware vendors. Some of them are like a 3DNS type of global DNS load balancing. But essentially, a way to have one namespace for all of your users, and then users coming into the appropriate data center based on their IP address. So typically by region, right? So you've got a North America or Europe, for example. A regional user would come into their regional data center based on the DNS query being responded to in that GTM-style solution. We're releasing guidance on that later this year as we work with some of the capabilities around that. But people have questions. Okay, I see how you do load balancing for high availability. What if I want to do load balancing across sites, right, or have some sort of automatic failover between sites? So we're coming with that information. There's a couple of hidden slides in here that go into some more detail as well if you have any questions. So with that, please fill out your evals. Thank you for coming and learning all about load balancing. If you have questions, we'll be happy to take questions. I'll also be at the booth area later this afternoon. So thanks again.